This video is about chemical risk assessment for research labs, and it introduces a software tool called labHIRA. Let's imagine that you want to start working with an unfamiliar chemical, or you want to scale up a synthesis, or you've not used the chemical for quite some time, or a new researcher has joined your research team. Under all those scenarios, one of the basic things you've got to do is get acquainted quickly with the potential risks of handling that new chemical. The normal solution, the normal approach, is to go ahead, collect relevant data from the normal sources, safety data sheets, National Institute of Health, Global Harmonization, EPA, and so on. Lots of different sources you can go to. Once you've gathered all that data, review it and then assess it to see what it's telling you. And from that information, determine the risks involved with using that particular chemical. Finally, once you've evaluated the potential risk, proceed accordingly. Alternatively, and what we're going to be talking about in this video, is a 5-minute risk assessment that is aided by labHIRA. And the intention of the 5-minute risk assessment is A, that it can be done quickly, and B, that it'll show you the potential hazardous situations that using that chemical could get you into. The results of this risk analysis help research personnel determine 3 important things. Is their knowledge of the chemical hazards sufficient? Are the in-place facility and lab safety systems adequate? And do the PPE that are provided provide appropriate protection? This 5-minute RA provides a solid basis for researchers to decide whether it's okay to proceed on, or that the hazards are such that either you don't understand them well enough, or you don't believe that, for example, the in-place facility safety systems are up to the task. In other words, a formal hazard identification is now going to be performed to make sure that indeed you're going to end up with a safe environment. Most of the time, you'll proceed on. Let's take a quick look at what formal risk analysis is all about, or risk assessments. 3 questions are asked. What is the nature of the upset? What is the magnitude and consequence of the upset? And what actions are needed to prevent or mitigate the upset? Now, I'd just like to note here that for R&D, we will consider that the likelihood of occurrence is constant and low, and therefore it's just simply not part of this discussion. We are going to focus on the magnitude and consequence of the upset. So labHIRA is a self-contained software tool that performs the 5-minute risk analysis for the chemical of interest and presents the results as risk rankings on your laptop or mobile device. The information that labHIRA uses includes toxicology and exposure, acute health and chronic effects. It'll also include GHS codes. We also need to know physical properties and flammability data, first aid and spill management, and a government program called Protective Action Criteria. And finally, we do need to know about, for purposes of handling, reactivity and compatibility, and are there any accident reports involving this chemical. labHIRA pulls all that together, and to show you what I mean, I'm now going to run a demonstration of labHIRA using dimethylformamide as our test. So this is the opening screen for labHIRA, and you can see that it's composed of 2 pull-down menus. This one here, which is for CAS numbers. If you know the CAS number, you can select it off this list. This is for selecting from the name, and then you can actually type in the CAS number here if that's the way you want to go. So let's use the pull down for the of the names, and we're going to come down and look for dimethylformamide. So we're in diquat. Let's go up a little bit further. You can see this is a little bit fiddly to do, but I wanted to show you all of the things that we can do with this. Now here's dimethylformamide. Click that, select it, and that gives you the CAS number and a name, and we're going to run labHIRA. Now labHIRA is running off its internal databases, and here is a summary screen. What this is telling us is the toxicity is pretty low. The things to be worried about anything with a 4. Chronic effects, potent liver toxin. Cancer, it's been flagged by ToxNet. GHS notes reproductive toxicity. The overall hazard rating is a 3.2, which means that this is moderately hazardous. And just in case we want to make sure we've got good level of data coverage. The data quality here is 0.92 out of 1, so that's a good coverage. The screens on the side here are 13 buttons, and this allows you to elaborate on any one of these summary pieces here. So let's look at toxin exposure standards, and you can see that right now what we've done is we've pulled up 3 pieces of information about tox, the exposure data, the immediately dangerous to life and health, odor threshold. So we've got a lot of information here that's not shown on the summary screen. So if you wanted to get into more information, then that's the way you go about this. The other thing to notice is down the bottom of the screen, we are replaying the tox hazard and the exposure hazard off that summary screen. We also indicate in this box the PPE that is required. Now let's go and look at GHS codes. And again, you can see the GHS codes are shown. Here are the GHS code rating number, the code numbers, and there are the single word hazard levels and describing what this is all about. Overall, the hazard rating for GHS codes tells me that this is a 4. Let's take a look at hazard handling and storage. And handling and storage, it talks about various things one should be concerned about when storing dimethylformamide in this box, and some incompatibilities. And again, the summary information is presented in this box down here. Now let's decide that let's assume now that we've seen enough, although we can obviously go through each one of these 13 boxes. We could either go back to pick up a new chemical, or we could have exited labHIRA. Let's exit labHIRA right now. So here's a summary of what we've learned from labHIRA for DMF. It tells us that the overall hazard is 3.3 out of a maximum of 5, and the DQ, by the way, is the data quality, the data coverage that we can obtain from all these different sources is about 92% of perfect. That's a very good data coverage. We also learned that THF is absorbed through the skin and there's damage to the liver. It's been flagged by ToxNet as a cancer hazard and also by GHS as a reproductive hazard. It is flammable, but not. It is combustible rather, but not flammable, and it's not particularly prone to hazardous reactivity. So the takeaway message for this could be summarized as simply: you've got to focus on PPE to protect yourself. Now let's do the same thing, but this time for a lot more reactive chemical, thionyl chloride. So this is the second demonstration using labHIRA, and this time we're going to look at thionyl chloride. For the purpose of the demonstration, I'm going to type in the CAS number 7719097. Click to find the chemical name. There we are, thionyl chloride, and labHIRA has pulled up the results. A few things to notice straight away. As you expect, if you know anything about thionyl chloride, inhalation may be fatal as a result of spasm and so on. Yes, that's no surprise. Serious eye damage. Very reactive with anything with an active hydrogen, reacts violently with dimethylformamide, and so on and so on and so on. As we well know, thionyl chloride is a difficult chemical to handle. One thing I want to point out, we can go to look at more information about a particular chemical by going out to any one of these websites. Now, I would hasten to add that unfortunately in making this this video, we were not able to get the video to recognize the pictures coming back from PubChem or ToxNet or wherever. So unfortunately you can't see that happening. As they say, trust me, it does work nicely. So let's go back to labHIRA, take a quick look at storage and spill and fire management. And here we have the information you would expect, what to do with in the case of a fire, how to handle a spill, PPE that we're going to need when we're doing this. And I think you're getting the point now that labHIRA can very quickly tell you an awful lot about this particular chemical and what we are going to have to face. Flammability and explosibility. Now, no surprise, because thionyl chloride is not flammable. We have no flammable information here. We do have a little bit of information about the boiling point, melting point. Vapor density isn't available, vapor pressure at 25 degrees centigrade. So as I said, there's an awful lot of information here that labHIRA can give us. And now again, as I said, at this point I can go back to get a new chemical and then proceed on as we were doing before. Right now again, I'm going to exit labHIRA. So this is the summary of the labHIRA analysis for thionyl chloride, and as you saw, this is a much more hazardous chemical than THF. The overall hazard rating is 4.4, good data quality. No surprise, it's violently reactive with active hydrogens. The health impacts are severe, possibly fatal, and that there are a series of unexpected reactions with water, moist air, that could be factored into thionyl chloride use. And note also the maximum exposure limit is only 0.2. The takeaway message here is a formal risk analysis is highly recommended for first-time users of thionyl chloride. So that gave you an overall view of labHIRA, and there's a few things to stress. labHIRA is not merely a redisplay of a safety data sheet. All of the information that you saw on the sheets for thionyl chloride and DMF are generated from the data that is held within labHIRA. labHIRA focuses on the chemicals and how they will be used based on their hazards. As you saw, it assigns an overall risk ranking. It also highlights the problems with each particular chemical because each of the various elements that you saw in the summary have their own risk ranking. So you can see immediately that labHIRA will emphasize those aspects of the chemicals that may require extra care and diligence. And again, labHIRA provides a solid basis to decide whether to proceed on or conduct a formal hazard analysis. And you can see that all this took a very short period of time. Thanks for watching, and if you have any questions, you can contact me at these two places, the web address and my email. Thanks again.